the camera. Say cheese.
Have you ever wondered how digital camera works? Then go with me. We'll break it down into a few basic parts.
Light enters the camera through lenses, then is focused to center point. When you click the shutter button, the moving mirror flips upward, and the light reaches image sensor and forms an emitted image. But when we see the image through viewfinder, it appears upright. When the shutter button is released, the moving mirror returns to its initial position. A pentaprism in the camera rotates the inverted image upright.
But how does light enter the camera? For example, if I want to take the picture of tree that cannot generate light, light enters the camera because of the reflection of light. Let me explain. The sun, stars are natural sources of light, while the candle flame lamps are artificial light sources. Almost all of the other objects that we come across cannot emit their own light, such as tree. Only we are able to see them because these objects reflect the light.
Sun emits light in many directions, but in our example, let's consider only a ray of light which strikes a tree. This ray of light is called the incident ray. The point at which the incident ray strikes a tree is called the point of incidence. The line perpendicular to the trunk of tree through the point of incidence is called a normal. When the incident ray strikes the tree, it will bounce off the tree. The ray which bounces off is called the reflected ray. Now, let's learn two laws of reflection. First one is angle made by the incident ray with normal is always equal to the angle made by reflected ray with normal. The second one tells us that incident ray, reflected ray, and normal all lie on the same plane.
Okay, but how does camera determine the color of objects? Color is only light that humans can see. The visible light is a tiny part of the electromagnetic spectrum.
Electromagnetic spectrum is a range of all types of radiation released from the stars, including our own sun.
Electromagnetic radiation travels in waves. The difference between colors is due to two factors. These factors are wavelengths and frequency. Wavelengths measure the individual wave emitters. Frequency describes how many waves per second a wavelength produces. Visible light spectrum ranges from a violet light, which has a wavelength of about 400 nanometers, to a red light, which has a longer wavelength of about 700 nanometers. Going back to our example.
Sun emits all colors of light, so light of all colors is hitting tree. The tree looks green because it reflects green color more than it reflects the other colors. Other colors get absorbed. When we click the shutter button, green light reflecting from the tree will enter a camera and reach a sensor. The job of the sensor is to pick up colors on a light reactive surface and convert them into electric signals. These electric signals then can be translated by a computer into an image that can be displayed on any type of screen.